Yeah, so thank you for the kind introduction. So as you all mentioned, if you are older folks in the SUMO society, we are new. So this year or last year we started to using SUMO for our project, and we want to use SUMO for digital twins. And before going into the deep, we do have an issue, and this issue is that we want to simulate traffic without any personal reference. So using traffic data that is in line with the laws of privacy, and therefore, we came up, okay, can we use SUMO in this kind of setting? And as usually, I start with a comic, and this is all my students knew that my comics have something related to the topic, and here we go. And 2 years from now, everyone noticed that this could continue like this, so that the artist is painting a beautiful picture. And nowadays we do have this, so that people starting to create a prompt, and by the use of AI we picture this woman. And what is more gentle and what is more nice, this is something you might decide. However, the first image is with personal reference, and the second image is without personal reference. So the first image is not if you do not ask the person in forehand, and the reality of the paint is in this way that the people or that the woman is can be identified really nicely. Then it's with personal reference, and the other thing is without personal reference. And we want to simulate traffic without the reference of vehicles. And this is where our project of intelligent intermodal commuter traffic is about. We are a consortia of the Stadtwerke Osnabrück, of the bus companies of Osnabrück, of University of Münster, of University of Applied Science Osnabrück, as well as other industry partner. And Osnabrück and Münster, this is not the famous city all of you should know, but they are nice little cities with a population about 160,000 and 300,000 people, and we do have a lot of traffic in the cities and between the cities. And the big thing is how to create a digital twin without breaking any law restriction. As you know, in Germany we are not allowed to track traffic plates. So we are not allowed to store traffic plate numbers, and we use this information later on. And therefore we will have a close look to the data of a crossing. And by going to a crossing, this is the famous crossing in Osnabrück on the Wall. We are looking, okay, what can we measure without personal reference? And the first thing is that we can identify the numbers of right turners, the numbers of left turners, the numbers of trucks per minute, the number of cars per minute. Then we can count on the pedestrian light the number of pedestrians. Then we can count in the buses the number of passengers, the delay in minutes, the position of the buses, as well as the route. Then we can also sense the bus stops, so how many passengers are waiting on the bus stop, the delay of the buses coming into certain bus stops, the position of the bus stops. This is funny because we recognize that even the city does not know exactly where the bus stops are located. They only have a rough idea. It could be on this edge, but no one catches the GPS position of the sign correctly. And then, of course, we do have the bicycle lane, where we can detect the number of bicycles, the direction, and the lane quality. And the last thing that we could measure is the parking lot, so how many parking lots are occupied and the type of parking lots. So in the 17th, our city say, okay, we want to be a city of future, and they remove all public transportation because car is the future. And this was nowadays a bad decision, but in these days it was a valid decision, and so we do have a lot of parking lot, we do have a lot of roads, but we did not have any longer any train or a light railway or other things, unfortunately. And the last thing that we can measure is the environment, so the temperature, the wind, as well as the air pollution concentration. And this leads us to the routes of the people traveling through the city, and we do have the cars, we do have the bike, and for a car and for the bike we have the origin and the destination, as well as for the bike, but we are not allowed to store any photos of the bicycle driver to re-identify the bicycle driver on the other traffic light. We are not allowed to store the number plate of the car to re-identify the car on the next stop. And so we have a non-concrete view of our traffic situation. So this is somehow black and white. And this is where we say, okay, can we use this macroscopic data, so the counting data of sensors, to simulate a microscopic simulation of our town? And this is where we looked to different tools. We ask our city, we discuss with other companies providing cities with such systems, and they say, okay, everything is closed source, and you can buy a module from us to do this, but we decided, okay, this is not the way we want to go, and so we say, okay, we do have access to all the sensors due to the Stadtwerke as well as the bus provider, and let's go for sensor-based traffic simulation. And so we want to know the routes of the pedestrian, of the buses, of the car, as well as the number of passengers within the car, the cyclists, the trucks that we do have, because next to the city we do have 2 highways, and if there is an accident on the highways, every navigation system say, okay, please drive through the city, and then there is a big traffic jam based due to the big trucks, and so on. And we want to improve the public transportation, we want to reduce the environmental pollution, we want to have a human-centered urban planning, we want to have traffic flow optimization, we want to have improving quality of the life within the city, we want to prevent accidents. Because why is this an important point? Due to the fact that we do not have any light rail system in Osnabrück, we have a lot of cyclists. And so we do have a lot of accidents with cyclists, and so this is a really issue that unfortunately there are a lot of cyclists that pay the price for the traffic with their lives, and this is something that we need to avoid. And then real-time traffic management. This is brand new to cities, that this is feasible and possible. And they are interesting concepts, and so on and so on. And therefore, we have a look to other cities. And one city that came in our mind is Barcelona, and Barcelona provides super zones, and the super zones, and in these super zones you do not have car traffic that is allowed to pass these super zones. So you can enter the super zones, but you will leave the super zones on the same direction as you entered. Then the city of Münster has a new system for guiding bicycle riders. So if you see this greenish over here, then you have the perfect speed to match the next green bicycle light, and so you have a flow system for your bicycles. As well as the city of Groningen. The city of Groningen say, okay, we have some one-ways in our city, and we want to, therefore increase our things. And all this are static, and we do not want to have static things in the city. And usually if you set something like this static in the city, you do not know how this works in forehand, and so we want to simulate the different things that you can build on the city. And then we discuss in the project team, what can we do? And the first thing, as the big companies say, okay, we ask the people wear GPS tracker so that they voluntarily offer their data to us, and then with the voluntary data we can model the traffic. And who of you is voluntarily sharing their data? Only one. Only two? Three? Okay. Who of you read the license agreement of Google Street and other navigation services? So have in mind that all of you, or most of you, by navigating with your phone, you provide the data to the big companies. And the big discussion is, what can we give the users to share the data of their GPS tracker with us? And the city have a good idea and say, okay, everyone who shared the data with us will get one coffee for free. And yeah, so this is an approach that does not work, because we do not have something to offer. So you use the services of Google Maps or other things because you get in return a good navigation system. You use other tools because you get in return a good functionality and working software. But for a city, what will a city return? And so having GPS, it's something that from the idea worked perfectly, but unfortunate, the coffee idea is lovely, but does not work out. Then the next idea were, okay, we placing cameras. So we do have our infrastructure placing their surveillance cameras, and from the technical point of view, it's not a big issue to re-identify people. It's not a big issue to detect a number plate and to re-identify the number plate. But then our lawyers say, okay, this is not clever, and this is forbidden to track people in the city, even if you are working with the city, and so this does not work out. Then the next thing, this is the way we are going right now, is to have some sensors on our infrastructure, and these sensors are counting sensors. So we are counting how many people are there, how many cars are there, what kind of cars, what kind of people, what kind of bicycle drivers, and so on and so on. And based on this data, we can somehow theorize where the people were going in the city and use this theoretic path to simulate our traffic. And the interesting thing by talking to the city where to place the sensors is that not every traffic light is owned by the city. So if there is a street that is built by the federal state and not by the city, then the traffic lights belong to the federal state. And there you need then an agreement that you are allowed to put a sensor on the traffic light from the federal state. So it's not as simple as it sounds. So there's a lot of things going on here. And this ends up in a lot of work that we are currently doing to drive SUMO towards a digital twin. So we are working with SUMO since half a year, and what we did so far is that we have all the static data and we put all the static data to create our traffic network. Then the next thing that we are right now setting up is by the use of passive infrared sensors and smart cameras that we do have macroscopic information, so counting information of our real data. And these number plate recognition, this is something that we are discussing with our local lawyer, that we are allowed to store a checksum of the number plate if the checksum is generated directly within the camera and not transferred to a server. This is somehow tricky. All Germans know that this section control is still forbidden in Germany due to the fact that we are storing the number plate data, and we have maybe a clever concept to get this information. And with this real data integration, we can do the simulation. And on top on the simulation, we want to connect to our real-time traffic computer of the state and also integrate this data and then have a digital twin. And with the digital twin, we want to answer if-else scenarios. So, for example, if you close this route or if you change the speed of a certain thing, then the traffic will behave in this way. And I got the sign that 5 minutes is left. So static data, this is something that you all know by working with SUMO, that we embed the GIS information, that we create a traffic network, that we define the sensor positions, that we define the positions of bus stations, etc., etc. And we put it in our QGIS, and here we go. Here we have the OpenStreetMap and then the detailed information on the traffic light systems and where we have the traffic light things. Then we also recorded 360 degrees videos on our own. And we try to match all of this. What is so this is the easy steps, so 360 degrees recording, and then use this recording to get a GPS position, etc. This is easy, but the hardest thing is to get the traffic light information. And we ask for a standardized format, and we get PDFs. And a student of mine is now writing his bachelor thesis on how to identify this traffic light schedule, and it's quite important. We do have different traffic light schedules, and for me as a traffic expert, it was completely new that the traffic lights only have different programs and not were configurable complete freely. So they have only state 1, state 2, state 3, and all of these different programs or states are written in one beautiful PDF. And then you need to re-identify which light on this traffic light has which cycle for switching green, red, and yellow. And therefore we are capable to simulate quite beautiful our crossings. And with the dynamic data, we are now starting to position passive infrared sensors for counting the number of traffic, for measuring the speed, and for measuring the different roads by the vehicle length, so how the vehicle is turning. Then smart cameras, we are also going to put smart cameras in the city, and further sensor technology. This is something not yet in the project, but in other projects that we can reuse or use for our things. And these are our dependencies, requirements, so turning behavior and speed. And with this thing we are creating first temporal data, and you see that we have also blanks in the temporal data as usual. And by having this data together, we can, or we might, generate the data from the count data, and this is where we stand. And the outlook is that we want to collect and fuse traffic data of 1 year and provide this data to the public, because I think this data from Germany could be a big value. Then we have the challenges right now is to get the correct metadata, because we have also a LoRaWAN network in the city, and the metadata is not good documented, and there's a lot of work to do. And we want to have our macroscopic data and drive with the macroscopic data in microscopic simulation, and this is where we are currently working on. And as I say, okay, I start with a comic, you will also get the solution of the comic. So if you put this prompt in today's computers, you will get this result. So this is stable diffusion, and we are hopefully to do the same by having the counting data and putting this counting data in a clever algorithm to be more or less close to the reality in the simulation of traffic. And this is without any personal references, but close to reality. And so, thank you.